Today I'm here with Dipti. She's a Flux maintainer. She helped us from the Microsoft side. She's very involved into Flux, and I'm very thankful for her to be joining me. And we are going to give you an overview of what this GitLess GitOps means. Then Dipti will show you some magic that can be done with Flux in Azure. And finally, we are going to talk about Flux roadmap and some things we shipped in Flux 2.7 that you may find exciting for your existing Flux state. Okay, so before talking about GitLess GitOps, let's talk about GitOps. So I'm guessing this slide looks very familiar if you are using Flux or Argo or I don't know, Jenkins X, whatever is there. In the let's say traditional GitOps pipeline, I used to say traditional for CI/CD like some years ago. Now GitOps has become the traditional pipeline. So in the traditional pipeline, you have basically a split in the desired state. You have a Git repo, or one, maybe more, where you store your YAMLs, your charts, everything that's part of the configuration, and you have one or more container registries where you store your container images. So every time you want to change something on your cluster, you have to modify both storages or however there are there. So basically, in the GitOps idea is that you change something in the desired state, Flux will reconcile the cluster, all the clusters, and it will try to bring the cluster as close as possible to the desired state. This involves drift detection and drift correction. And this happens based on the state of your Git repo. Now, this is a little bit more complicated because you also push images to the container registry. And Flux has a feature, I'm guessing if you're a Flux user, you've heard about this, it's called image automation. So Flux can scan the container registry based, let's say, on semver or some other policy that you define. It's called an image policy. And then we'll write back to the Git repo the new version of the app, then another part of Flux will synchronize that on the cluster, right? So it's not a straightforward idea about desired state. It's always in these split storages. And we have this since Flux 1, since, I don't know, 2016. When we started Flux version 2, we created this dedicated controller called source controller that deals with sources. Of course, the first implementation was Flux looking at the Git repo, and the source controller connects to the Git repo, downloads the content of the Git repo, and what happens inside Flux, it bundles the content into what we call the Flux internal artifact, which resembles very much to an OCI artifact. So we already have in Flux itself a way of storing configuration. Why we do that? Because we want Flux to survive, disconnects from the Git repositories. If the Git repo goes down, that means that you should still be able to maintain drift correction if something happens with the cluster. Let's say Git goes down, someone goes in your production system and does kubectl delete deployment. Hopefully you are not allowing your users to do that, but let's say they do. Even if Git is down, Flux will still reconcile and put back the deployment. Why? Because source controller has this cache, if you want, of all these artifacts. So this was the first implementation. Then we thought, how about we allow other sources than Git? And the second implementation we did there was the most popular storage out there? S3, right? Everybody uses it. So the second implementation was actually S3. S3 comes with its own challenges in terms of versioning and determining what's the exact version that I have in S3. But last day at FluxCon, Tiffany did a great talk about Flux at Morgan Stanley, where she showed how, bucket is, S3 is used as the desired state for the bank because regulations, because, all sorts of requirements from the company itself they had to go on that way. The third thing that we've built into Flux was looking at container registry as desired state. And it looks like this. What this means is that we can use the container registry, which is already in there in your clusters, as storage for, of course, Helm charts, Flux configurations, Kubernetes configuration, and container images. And this has, in my opinion, major advantages since we've implemented this. I've been preaching it all the time. Try to use this GitLess GitOps approach if you can, because first, it simplifies the way you sign and verify everything in your infrastructure, right? Once you push all these configurations, Helm charts, and so on to the container registry, being OCI artifacts, you can use the same tooling for signing and verifying. And Flux integrates with cosign, with notation, notary notation. So you can have the same policies for verifying that whatever is happening in your production clusters, the new desired state is the thing that's authorized to be there. And we also support cosign with the keyless approach, where you sign your artifacts with an OIDC identity of, let's say, your GitHub runner, GitLab runner, and so on. So it's not about, in Git, when you sign something in the Git repo, you sign it with an open PGP as an identity of a human. Here, the identity is not of a human. Here, the identity is the machine that has produced that artifact. So I don't think these things are interchangeable. Is it better to verify and, look at signatures from a machine perspective? There are definitely some advantages. One of the advantages are that in here, in the container registry, you can also have an SBOM. You can also have attestations about the environment where those artifacts were produced, right? Not just the information who did the commit, the human that did it, right? The only thing that you can verify in Git. So there are major advantages from this, security perspective. But there are also advantages from availability perspective. Maintaining Git and having Git part of your production system, this is what GitOps means, right? Git becomes part of your prod. You need to do on-call, you need to scale it, you need to secure it. It's really, really hard. And some of the big cloud vendors out there actually proved it's so hard that they shut down their Git services and told people, go to GitHub. I'm not going to name the cloud vendor, I'm guessing everybody knows. So, yeah. Having Git in production is not the best thing. So, a container registry is already there. It's a requirement for your clusters. You have to, deploy apps. It's way easier to have it HA. It's way easier to copy content across regions. And it reduces the latency between Flux and the desired state. Usually it's regional. Flux can go to the container registry, pull all the things faster. So all of this together, I think there are enough advantages for you to investigate. Of course, there are extra steps that you need to do. In a normal GitOps solution, you run Flux Bootstrap, give it an SSH key, and you are basically done. Here, there is a CI component to all of this, and I'm going to show you a little bit what it means. Before the CI component, let's start with the manifest. So if you start with GitOps and Flux Bootstrap, what you will be using is a Git repository definition, right? You give it the URL, you give the server, you verify it with the list of known PGP keys that the humans that are authorized to make changes on the cluster. If you want to migrate to OCI repo, it's not that different. The APIs look quite the same. The major change is in the verification part, where instead of verifying a PGP key, now you can say provider cosign, and you give it this is the keyless verification. When we check that the machine that has produced this artifact originates from the repo where the app is, right? So if you create this artifact from a fork or from a different repo, the cluster will reject it and say, not authorized, I will not be applying this configuration. So I don't think it's quite hard. I've seen Flux users building tooling for doing this migration from one to another. So this is for, when you use Flux customizations to apply YAMLs and customize overlays. Instead of Git, now you can apply them from a OCI artifact. Next, Helm. Helm has great support for OCI, right, for a very long time. But we still have this issue. There are HTTP Helm repos everywhere. I encourage you to make the switch. How you can do it with Flux, let's say, if you had a Helm repository, an HTTP one, you'll have to create a Helm repository object, then a Helm chart object, so you'll have to create two things, and the Helm chart will be referenced in the Helm release. With OCI, the API is way more compact, and I think it's a way better approach to do this for Helm charts, where you declare the same object, OCI repo, but there is that field layer selector which tells Flux, expect in this OCI repository to find an artifact of type Helm. So Flux basically takes the Helm chart, does not touches it, it takes it, it can verify it with the same tooling, cosign, and exposes it inside the cluster. So it's a unification of storage from outside, but it also changes a little bit how you deal with Flux and how you think about, Flux objects and sources. Ideally, you'll deal with only one source. You don't have Helm repos, Git repos, Helm charts. You all have OCI repository everywhere as a source, and kind of simplifies also the way you think about structuring the Flux workflows and so on. Okay, so this is the part of the API that you have to change to move to OCI repo, and now let me show you a little bit what it means in continuous integration. So like Docker, Flux has a push command. There is a big difference here where we have this source and revision as mandatory fields, and I'm going to explain to you why this is needed. When you push content to the registry, maybe you want to know on the cluster which was the original source of the artifact contents. And this is how you can do it with the Flux CLI, to add a trace where you snapshot the origin, what is the Git repo, what is the SHA, what is the branch. This information, Flux can understand it, and it can even write back to Git based on it and say, this commit was deployed. Or it can send you a notification on Slack and say, yes, I have reconciled, I don't know, cert manager with this configuration with the origin source, this Git repo, right? Because your developers, your platform admins, they will not be working with OCI at all. OCI is just an intermediary storage, a buffer between Git and the cluster. So this kind of tracing is critical for a good user experience, where when you inspect, you do Flux trace, all the things on the cluster, you see what's the original Git repo. So GitLess GitOps is still GitOps, right? Because Git is where you collaborate on changes, from where you author all the things, and Flux is able to tell you what's the original source. And to see how it all works together, at ControlPlane we created a GitHub action that you can use today. It's called push, and it allows you to, hook it to the git commit branch merge event. Every time you push it, it will push to GCR, it will sign with cosign, and makes it very simple. So it's not that complicated to add these 2 small YAMLs to your GitHub workflows in order to adopt Flux with OCI artifacts. So hopefully I have convinced you that this is a good thing to do. One last thing around, we also I work a lot on this Flux operator, which sits on top of Flux and has some very nice abstractions. And here is how you can bootstrap clusters from 0 with OCI repository as the source. Right? The Flux instance is a configuration for Flux operator to deploy Flux itself. And while it deploys Flux itself, you can also configure Flux to sync the whole desired state from a source. Of course, it supports Git repo and so on, but it also supports OCI repository. And what's important here to note is that sync has a provider, and in this case is AWS, because she is Microsoft and I have to promote another cloud. What this means is that Flux, you tell Flux, hey, you are running on AWS, you don't need an image pool secret for this OCI artifact. You should be using the workload identity, either of the node, or of source controller, or the service account, and access this repository without using any passwords. And Flux knows how to do the handshake, gets an ephemeral token, access, in this case, ECR, and downloads the source. And Dipti now will show us how we've built into Flux this type of passwordless authentication, not only for OCI, but for the majority of services that Flux integrates with. Dipti?
Hi, everyone. Thanks, Stefan. So as Stefan mentioned, I'll be demonstrating the OIDC integrations in Flux that enable passwordless authentication. I'll start with the high-level scenario, the challenges, and then have a demo around how this is solved. So here we have Flux deployed in a hub-spoke architecture, where Flux is deployed on a centralized hub cluster, and it's managing the continuous delivery of app and infra workloads on remote staging and production clusters. The Flux controllers, they pull artifacts from Git repositories, OCI repositories, Helm repositories, like Stefan mentioned, and they push these workloads onto these remote staging and production clusters. As newer versions of your app and infra images are pushed to container registries, the Flux controllers watch these container registries. They work with image update automation APIs to patch your images in your repositories. And after successfully or unsuccessfully reconciling the commit, it can send notifications. So for successful commits, it can update the GitHub commit status. For failed notifications, it can send notifications to subscribe providers, for example, PubSub providers. So this is a very powerful workflow. However, to typically achieve it, there are a number of secrets that are involved. For example, the Flux controllers, they need access to SSH keys or personal access tokens to pull or push to your Git repository. They need access to kubeconfig files to push workloads to these remote staging and production clusters. Similarly, we need access keys for fetching tags and sending events to PubSub providers. So these credentials are typically stored within your Kubernetes clusters as secrets. And that really makes the hub cluster, which has the Flux installation, a really high-valued asset and also a prime candidate for security attacks. To minimize some of the security risk, you might choose to rotate these credentials often. You might also be required as part of your organizational policies to rotate these credentials. But that just puts significant burden on the cluster operator to, again, reconcile and reload these secrets on your Kubernetes clusters. With the OIDC integrations with the cloud providers, this entire workflow can be achieved in a completely credential-free manner, just using short-lived OIDC tokens. So I'll be demonstrating this for with the Azure cloud provider with Azure DevOps repository, but it works the same with OCI repositories across cloud providers as well. So here I have 2 AKS clusters and a managed identity in my Azure resource group. The Flux hub cluster is the one that has workload identity enabled and has the Flux controllers running on them. The Spoke cluster is the target cluster that Flux will be deploying the workloads to. The managed identity, if we look at the assignments, it's been given access to the Spoke cluster to push workloads to it. It's also been federated with the service accounts of the Flux controllers, extending the same access to these Flux controllers. If we look at the Azure DevOps repository, I just have a sample deployment here, and it has noticed that the image tag has been marked with an image policy marker. The managed identity that we saw earlier has also been given read-write access on this Azure DevOps repository, and the Flux controllers have the same access. Looking at some of the specs, the Git repository spec points to the Azure DevOps repository. It has provider set to Azure, but no other secrets in the spec. Similarly, the customization points to the Git repository. It has a config map reference, but no other secrets. If we look at the config map, it simply points to the Spoke cluster, which was our target cluster, and has the provider set to Azure. Lastly, this is the notification spec for updating the GitHub commit status. Again, no secrets here. So to simulate a day-end operation, I will just create a new container image tag and push this image tag to my container registry. Behind the scenes, the image reflector controller works with the image update automation APIs to push a new commit to our Azure DevOps repository. So we see that a new update has come from the Flux CD bot. And if we look at the contents of the repository, the image tag has been updated to the new one that we just pushed. Now, source controller and customized controller work to pull this artifact down onto your hub cluster and reconcile the workload on the Spoke cluster. So here on the Spoke cluster, we see that the older image is present. But if I refresh, we'll see a new rollout starting for the newer image tag. So now that this commit has been successfully reconciled, if we go back to our Azure DevOps repository, we'll see that the notification controller sends an event to mark the commit as successfully reconciled. If there was a failure, we could have sent a notification to a PubSub provider, in this case Azure Event Hub, to further act upon that failure. So in this example, I used a single managed identity, and that was given access to all the resources. But Flux also allows for the flexibility to configure this at a per object level. So for example, if you had multiple Git repositories that was used within a single Kubernetes cluster, you could also associate different identities at a per object level. So this enables some really powerful multi-tenant scenarios for your Kubernetes clusters. Lastly, I want to give a big shout out to Matthias, who is our upstream Flux CD maintainer, who took the lead on this per object level identity design. Yeah, I think that's all I had. Thank you, Stefan.
Yeah, it's awesome. No more passwords. I mean, this took us almost 1 year effort. Yeah, big thanks to Matteo. Sadly, had to go back today home. But he pulled this off. It were a couple of RFCs, especially around kubeconfig. It was really hard because each cloud has its own little thing there. Workload identity is quite the same, but when you connect from one cluster to another, there are all sorts of specifics. So Dipti also helped us a lot with Azure, test all the things, and Mateus did Google and AWS. So these are the 3 cloud providers that we support in Flux, and every feature we add to Flux, we have to do it in all of them 3. This is how we ensure, Flux is not specifically made for something. People has asked us, like, why don't you expand this? Like, why not more providers? Like, cool, if Oracle Cloud wants to donate a maintainer to Flux, we are most open to integrate with their workload identity, but it's a lot of work, and it's really hard to maintain all of this. Kubelet has these out-of-trees integrations, right? In Flux, everything is inside Flux. We don't go to some other daemon to give us tokens and so on. So we had to work with all the cloud SDKs and implement basically this on our own. But the achievement is quite great. You can, like Dipti said, you can connect to any kind of service, get data into the cluster, get data outside of the cluster with zero passwords. And this enables a different type of, bootstrap. If you think about ephemeral clusters, the fact that you can just do a deploy a Flux operator and then nothing else, no secrets, no nothing, and you get the ephemeral cluster, you provision it, you run your end-to-end tests, then you destroy it, right? It can really, bring this idea of I can throw around clusters, it's like containers, right? It becomes way more easier. Okay, next I want to talk about some new features that we shipped into Flux. Still have time? 2 minutes? Oh. Let's make it 20 minutes. No, we are going for drinks. No, I'm not going to keep you here. The most important thing I want to mention, what we shipped in Flux 2.7 is this new, we added a new controller to the Flux GitOps toolkit. It's called Source Watcher, and it comes with a new API called Artifact Generator. What this allows you to do is it solves the problem of monorepos. If you ever worked with Flux and monorepos and you have hundreds of apps in the same repo, you modify something there, then Flux has to figure out from all the hundreds of apps which one was modified. It has to do dry runs and drift detection, drift correction for everyone. With the artifact generator, you can basically configure Flux to treat every single app in your monorepo as a unique and self-versioned artifact. So basically, it will create Flux internal artifacts. When something changes, only the app that's part of an artifact will trigger a reconciliation. So you can have thousands of manifests in the repo if you have some kind of structure, grouping the apps or having each app reconcile on its own. Only that part will actually change. In CI, we had this for a very long time. GitHub supports this when you can say, I want to trigger this CI workflow only if something in a particular path in the Git repo changes. So now we can have the same feature in Flux where you can do these kind of things. And you can also do the opposite with artifact generator. You can say, I want to compose an artifact from multiple sources. For example, you can say, I want to get the customized base from an OCI artifact and the overlay from a Git repo. Or I want to get my Helm chart from the OCI artifact, then the values of the Helm chart from another Git repo and merge them and rebuild the chart. It's very powerful. At FluxCon, there was someone staying next to me and showed me like, hey, we are already using this. It has solved so many problems for us. So if it's something to really look into, Flux 2.7, brand new API, take a look at Artifact Generator. Other things in the ecosystem, I'm guessing you know, we are into AI, deep in AI. We have a Flux MCP server. In the last day at KubeCon, I'll have a talk only about this. I'll not insist much around it. Another shout out, Backstage now has in their repo an extension for Flux. You are a Backstage user. Now you can use the plugin from the Backstage community repository. And this is maintained. If Backstage is your thing, now we have a supported plugin for it. And what's next with Flux? Of course, Helm 4, we want to integrate with it, and we have other nice things coming next year, early next year, Flux 2.8. And the last thing we announced at KubeCon, we have a status page for Flux. It's embedded in Flux operator. So if your users are crying that Flux does not have a UI, ta-da!